Good morning students. Today we are going to discuss about two topics. One is total probability of an event, another one Bayes theorem. Using these two properties we are going to complete the exercise 12.4. It's an important 5-mark question. Okay, first we will see total probability of an event. For that you see the theorem. If A1, A2, A3 etc. An are mutually exclusive and exhaustive events. Okay, look at this. This is your A1. So this part is A1 and here A2 and this is A3, A4 etc. AI or AN, they are mutually exclusive. Mutually exclusive events means there is no common outcomes between the events. So A intersection A1 intersection A2 is equal to null set. Okay, and B is any event in S. So the whole thing is a sample space and B is any event. Which is B? The green color part, this is nothing but B. So the green color part is nothing but the event B. And we are going to find the P of B. What is P of B? Is called the total probability of an event B. Total probability of an event B. So that is nothing but P of B is equal to P of A1 into P of B by A1 plus P of A2 into P of B by A2 plus etc. P of AN into P of B by AN. This is the formula we are going to prove this. So first you consider B. So the green part is B, isn't it? So here first you consider this part A1 along with B. So this part, what I have written in black color, this is A1 intersection B. This is the area where A1 and B is common to A1 and B. So therefore this part is A1 intersection B. This is A2 intersection B. This is your A3 intersection B, A4 intersection B, etc. So therefore the B event can be written as A1 intersection B union A2 intersection B, union A3 intersection B, union A4 intersection B, etc. AN intersection B. So if you join all the parts, you will get B. Okay, and look at this. Here what is given? A1, A2, A3, etc. They are mutually exclusive. These events are mutually exclusive. But what about these two? A1 intersection B and A2 intersection B, they are also mutually exclusive. So therefore this event and here that is A1 intersection B, A2 intersection B, A3 intersection B, A4 intersection B and etc. AN intersection B, everything is mutually exclusive events. So you know very well, if A and B are mutually exclusive events means the probability of A union B is equal to, what is it? P of A plus P of B. Okay, B is the union of all the terms. So if you apply probability, so it is probability of first one plus probability of the second one plus probability of the third one plus etc. probability of AN intersection B. Because if A and B are mutually exclusive, P of A union B is equal to P of A plus P of B. So that's why I have written separately in addition. Okay, so in conditional probability, so by the definition of the conditional probability, what it is, we can write P of, what is it, A by B can be written as, how it will be, P of A intersection B divided by P of B. So if you multiply these two, P of B into P of A by B. Okay, that is equal to P of A intersection B. In this way also P of A intersection B can be written as. Otherwise, one more result, one more condition we can take. P of B by A if we have. So it is P of A intersection B divided by P of A. So these two are the definition of the conditional probability. So from that also we can write P of A intersection B is equal to, what is it, P of B. Okay, so here P of A has to come, girls. So P of A into P of B by A. Okay, so see that either the conditional the definition of the conditional probability, we can write P of A intersection B is equal to P of B into P of A by B, or P of A into P of B by A. So here we are going to take this one, because P of B can be written as P of A1 into P of B by A1. அதே மாதிரி P of A2 intersection B can be written as P of A2 into P of B by A2 plus etc. P of AN intersection B can be written as P of AN into P of B by AN. So this is the total probability of an event. So P of B formula is P of A1. What is the probability of getting the event A1? That is P of A1. On A1, what is the probability of getting the event B? Plus the probability of getting an event A2. Here on A2, what is the probability of getting the event B? So likewise it goes on. So the formula for total probability of an event B is nothing, is denoted by P of B, which is equal to P of A1 into P of B by A1 plus P of A2 into P of B by A2 plus etc. P of AN into P of B by AN. That is the total probability of an event. So the next one, we are moving to the Bayes theorem. So here, what are the events? If A1, A2, A3, etc. AN are mutually exclusive and exhaustive events such that P of AI greater than 0. So it is not equal to 0. Each probability is greater than 0. For I is equal to 1, 2, 3, etc. N. And P is any event that probability also greater than 0 means then P of AI by B. P of AI by B can be written as, you see that, P of AI into P of B by AI divided by P of A1, P of B by A1 plus P of A2 plus P of B by A2 plus etc. P of AN, P of B by AN. Can you see what is the denominator? It is nothing but P of B. So simply we can write P of AI by B can be written as P of AI into P of B by AI divided by the whole thing. Just now we have seen it is the total probability of an event B. So it is denoted as P of B. We'll see the proof. Okay, P of AI by B. So we are going to use the definition of conditional probability. What has to come? P of AI intersection B divided by P of B. So P of AI by intersection B can be written as, you see that here, P of A intersection B can be written as P of B into P of A by B, you can write. Otherwise P of A into P of B by A. So this term we are going to take. How we can write this as? Again, using the definition of the conditional probability, this can be written as P of AI into P of B by AI. So therefore we will get the formula. So this is called the Bayes theorem. So you just remember that P of A1 by B can be written as, how we can write? P of A1, numerator term P of A1 into P of B by A1. Here A1 by B. Here you have to write P of B by A1 divided by the total probability P of B. This is called the Bayes theorem. Okay, I'll repeat for A2. P of A2 by B if you want to find out. So what do you have to write first? P of A2 into P of B by A2 divided by P of B. Okay, so that is the Bayes theorem. Using these two theorems, we are going to do the problem. Okay, exercise 12.4. See exercise 12.4, first problem. A factory has two machines, 1 and 2. Machine 1 produces 60% of items and machine 2 produces 40% of items of the total output. Further, 2% of the items produced by machine 1 are defective, whereas 4% produced by machine 2 are defective. If an item is drawn at random, what is the probability that it is defective? So here there are two machines, machine 1 and machine 2. So the items produced by machine 1 is 60%. Items produced by machine 1 is 60%. And 40% of the items of the total output by machine 2. Further, 2% of the items produced by machine 1 are defective, whereas 4% produced by machine 2 are defective. Okay, so if an item is drawn at random, what is the probability that it is defective? So see now first, here you see the diagram. Here I have taken the sample space, that is called the total output. So the sample space is total output. So the total output, the items are produced by machine 1 and machine 2. So A1 be the event that items are produced by machine 1. Okay, so this is your the items produced by machine 1. And here I have taken the next event A2. So these are nothing but the items produced by machine 2. Okay, and here what is asked in the question, if an item is drawn, if an item is drawn at random, what is the probability that it is defective? So what is asked, that has to be taken as B event. So let B be the event of drawing a defective item. So see now here what is given, 60% of the items are produced by machine 1. So therefore P of A1 is equal to 60%. 60% means what? It is 60 by 100. And P of A2. So P of A2, what is A2? A2 be the event that the items are produced by machine 2. In the problem it is given, you see that machine 2 produces 40% of the items. Okay, wow. So therefore P of A2 is equal to 40%, that is 40 by 100. Okay, so here next one, what is given in the book? It is 2% of the items produced by machine 1 are defective. So the B is what? It's a defective item. So P of B by A1. So it is, we have taken first machine 1. So in that machine 1, what is the probability of getting defective items from machine 1? That is 2%. So how I have written? P of B by A1. What is 2%? It is a defective item from A1. So first machine 1 we have selected. So the next we are going to see what is the chance of getting defective item from machine 1. So how it will be denoted? P of B by A1. That is 2%. That is 2 by 100. And you see that here in the sentence, whereas 4% produced by machine 2 are defective. So machine 2, the items produced by machine 2 is the event A2. So we have taken the items from the machine 2 and we are going to find the chances of producing defective item. So P of B by A2 is equal to 4%, that is 4 by 100. Here what is asked? What is the probability of getting the item chosen as a defective? So we have to find an item is drawn at random. What is the probability that it is defective? So only one item is taken and we have to find out what is the chance that item is defective. So we have to find the total. You see the diagram. Here what is A1 intersection B? So A1 is items produced by machine 1. What is B? B is the defective item. So therefore A1 intersection B is the defective items of machine 1 and A2 intersection B is the defective item of machine 2. So therefore the whole thing is nothing but B. Okay, but total probability, if you want to find out, you have to find out the whole thing. So P of B is what? It is P of A1 intersection B union A2 intersection B. So we have learned the total probability of an even formula. So what is it? P of B is equal to P of A1 into P of B by A1 plus P of A2 into P of B by A2. Okay, what is P of A1? So A1 is the even of that the items are produced by machine 1. So we have found 60 by 100 into P of B by A1 is 2 by 100. Next, P of A2 is 40 by 100 and P of B by A2 is 4 by 100. So you have to do the calculation. So it is 120 divided by 10,000 plus 160 divided by 10,000. So therefore if you add, it is 280 divided by 10,000 and 0 getting cancelled. So it's 28 by 1000. So therefore this can be written as 0.028. See the second question. There are two identical urns containing respectively 6 black balls and 4 red balls. 2 black and 2 red balls. An urn is chosen at random and a ball is drawn from it. So you have to choose one urn and a ball is drawn from it. So first question, find the probability that the ball is black. So you have to find the probability that the drawn ball is black. And the second one, you see that if the ball is black, what is the probability that it is from the first urn? Okay, so see the second question, if the ball is black, so we have decided the ball is black. So on that, what we have to find on that condition, we have to find what is the probability that it is from the first urn. So this is the second question. Okay, you see now, here I have denoted in the diagram, you see that 2 urns. Okay, so first another selecting, if you select first urn, that event is A1. If you select the second urn, that event is A2. So here the problem is regarding about black balls, isn't it? So let B be the event of selecting black ball. Okay, so A1 be the event of selecting the first urn and A2 be the event of selecting second urn. So see the first urn. So what do you have? You look at this. In the first urn, you will have urn 1. Okay, you will have, you see that 6 black and 4 red balls. Okay, 6 black balls and 4 red balls. Urn 2. Okay, so how many black balls? You see that 2 black ball and 2 red balls. So here you are having 2 black ball and 2 red ball. So see now here, P of A1. First we have to find out P of A1. Okay, what is P of A1? What is A1? A1 be the event of selecting urn 1. So 2 urns you are having, from that you have to select one. So the chances of selecting the first urn is 1 by 2. In the same way, P of A2, that also 1 by 2. Why it is 1 by 2? There are 2 urns, so we have to select the second urn means, so the chances is 1 by 2. Okay, and what is P of B by A1? So what is it? Urn 1. So first it is urn 1. We have to, on that urn 1, we have to find the probability of the black ball. That is P of B by A1. Or what is the probability of selecting the black ball from urn 1. That is P of B by A1. And the next one is what? P of B by A2. Selecting the probability of selecting black ball from the urn 2. Okay. And you see that what we have to find. So see the question. The first question, you see that first subdivision. Find the probability that the ball is black. So getting black ball is the B event. So totally you have to find out P of B. P of B, that is the first one you have to find out in the first subdivision. Coming to the second subdivision, if the ball is black, so first one condition we have taken. First, what it is? If the ball is black, what is the probability that it is from the first urn? It is from the first urn. So the question is what? P of what is it? A1 by B. So ball is black. So it has to be written in the denominator because this condition already happened. We have chosen the ball is black and we are going to find what is the probability that it is from the first urn. So first urn event is A1. So we have to find P of A1 by B. And coming to here. See, P of A1 already I have said it 2 urns. So the chances of selecting one urn is 1 by 2. In the same way P of A2 also 1 by 2. What is P of B by A1? That is, we have selected the first urn. Next we are going to see what is the probability of selecting black ball from it. So see, urn 1 having how many black balls? 6 black balls. Total number of balls is 10. So therefore the P of B by A1 is, you see that 6 by 10. There are 6 black balls in the first urn out of 10 balls. So therefore 6 by 10. What is P of B by A2? What is P of B by A2? The probability of selecting a black ball from the second urn. So second urn, how many black balls is there? 2 balls. Totally how many balls are there? 4 balls. So therefore the answer is 2 by 4. Okay, so next what is the question is asked here? So P of B. So it is the total probability of getting black balls. So the black balls may be from the first urn or from the second urn. So first we have to find out using the formula P of A1 into P of B by A1 plus P of A2 into P of B by A2. So we have found everything. So P of A1 is 1 by 2 into P of B by A1 is 6 by 10 plus P of A2 is 1 by 2. P of B by A2 is 2 by 4. So see now the 2 and 6 getting cancelled. So 3 by 10 plus 2 getting cancelled. It is 1 by 4. So what is the LCM? LCM is 40. So therefore it is 3 into 4 is 12 plus 10 into 1 is 10. So the answer is 22 by 40, that is 11 by 10. So next one, you see that P of A1 by B. So that means, so already we have learned the Bayes theorem. So P of AI by B. So Bayes theorem, if you use P of A1 by B can be written as first P of A1 into P of B by A1 divided by the total probability of getting black ball. Okay, so P of A1 already we have found it is 1 by 2 and P of B by A1. What is P by A1? The probability of getting black ball from the first urn. So we have found it is 6 by 10. So 6 by 10 divided by 11 by 20. So if you multiply 6 by 20 in the term, if you write it in multiplication, we have to write the reciprocal of it. So 20 by 11. So 20 getting cancelled. Here you are having 6 by 11. See the third problem. A firm manufactures PVC pipes in 3 plants X, Y and Z. The daily production volumes from the 3 firms X, Y, Z are respectively 2000 units, 3000 units and 5000 units. It is known from the past experience that 3% of the output from plant X and 4% from plant Y and 2% from plant Z are defective. A pipe is selected at random from a day's total production. So first subdivision, find the probability that the selected pipe is a defective one. And the second one, if the selected pipe is a defective, then what is the probability that it was produced by plant Y? Okay, so here 3 plants X, Y, Z, they are producing PVC pipes. Okay, the total production, okay, is nothing but from X plants is 2000, from the Y plants is 3000 and from Z plant is 5000. Totally the total output is 2000 plus 3000 plus 5000. So totally it is 10,000 per day. Okay, so per day the total production is 10,000 units from plant X, plant Y and plant Z. So on that 3% of the units are defective from plant X and 4% are defective from plant Y and 2% are defective from plant Z. Okay, so now we are going to select a pipe, and what we have to find first? Find the probability that the selected pipe is a defective one. So we are going to concentrate on the defective pipe. Okay, see that the diagram here, 3 plants X, Y, Z. So therefore we need 3 events. The first event is A1 and the second event is A2 and the third event is A3. So this is your A1, this part, and here this part is your A2 and this is your A3. So what is A1, A2, A3? A3 be the events that the PVC pipes are produced by the plants X, Y and Z respectively. That means A1 be the event that the pipes are produced by the plant X. A2 be the event that the pipes are produced by plant Y. And A3 be the event that the pipes are produced by plant Z. Here the problem is talking about the defective one. So we need one more event. Let B be the event of getting defective pipes. Okay, so therefore this green color. So the green color one is the B event. So these are all defective pipes. Okay, so the defective pipes may be from the first plant or second plant or third plant. So this is A1 intersection B, this is A2 intersection B and this is A3 intersection B. That means the defective pipes from A1 and this blue color is the defective pipes of A2 and the yellow color is the defective pipes of A3. Here first we have to find out P of A1. What is P of A1? The pipes, what is the probability of the what is that? The A1, P of A1 means what is the probability of that event occurs. So see that the total production from plant X is what? 2000 out of 10,000. Why it is 10,000? Total production. So it is 2000 plus 3000 plus 5000. So it is 10,000. So therefore 2000 by 10,000. And P of A2. So P of A2, the probability of getting the event A2. A2 is what? The pipes are produced by plant Y. So it is given in the book 3000. The total production is 10,000. So 3000 by 10,000. So if you cancel, it is 3 by 10. In the same way, P of A3 is 5000 by 10,000, that is 5 by 10. So next what we have to talking about, we have to talk about the defective item. So next we are going to see the probability of the defective item from the first plant. Okay, so P of B by A1. So they have given the ratio 3%. See the 3% of the output from plant X. Okay, so therefore 3 by 100. 3% means 3 by 100. Next, the defective pipe. What is the probability of the defective pipes from plant Y? That is 4 by 100 because 4% is given. So it is 4 by 100. And P of B by A3. That is from plant Z. What is the probability of getting a defective item is 2 by 100. You see the question. What is the question is asked? See the first subdivision. Find the probability that the selected pipe is a defective one. We are going to select one pipe. That selected pipe is a defective one. So defective items, if you are getting the what is the name of the event? B. So we are going to find that what is it? P of B. The P of B is a defective item. Defective items from the first plant production and the second plant production and the third plant production. All the 3 plants having the defective items. So therefore, using the total probability of an event formula, P of A1 into P of B by A1 plus P of A2 into P of B by A2 plus P of A3 into P of B by A3. So the values has to be substituted. So here it is 6 divided by what is that, 1000 plus 12 divided by 1000 plus 10 divided by 1000. So if you add, it is 28 by 1000. If you divide it by 4, it is 7 by 250. That is the first subdivision answer. Now coming to the second subdivision, what is asked in that? If the selected pipe is a defective, so which condition happened first? It is a defective. So defective items, if you are getting what event, it is B. So B is already happened. Then what you have to find, what is the probability that it was produced by plant Y. So the items produced by plant Y is nothing but which event? A2 event. So we have to find out P of A2 by B. Okay, it's a defective items. This has happened. We have selected a pipe. That pipe is a defective one. Then what you have to find? The probability of the defective item is from the plant Y. So therefore P of A2 by B. By Bayes theorem, how you can write this as P of A2 into P of B by A2 divided by the total probability of B. Okay, so P of A2, so we have written it is 3 by 10. P of B by A2 is 4 by 100. So P of B, already in the first subdivision we have found it is 7 by 250. Okay, so if you multiply 12 by 1000 into, here it is a reciprocate, what is that? I have written multiplication, so we have to reciprocate this term, 250 by 7. Okay, so 0, 0 getting cancelled, 25 and 100 if you cancel, it is 4. So it is 12 by 4, 12 and 4 getting cancelled, so the numerator is 3 by 7. So we have completed the third problem. See the fourth problem. The chances of ABC becoming manager of a certain company are 5:3:2. The probability is that the office canteen will be improved if A, B, C and B become managers or 0.4, 0.5, 0.3 respectively. If the office canteen has been improved, what is the probability that B was appointed as the manager? Okay, so see here the chances, 3 persons A, B, C, okay, the 3 persons becoming managers. The probability that the 3 person becoming managers are 5:3:2. The chances is. And the probability is that the office canteen will be improved if ABC becoming managers are 0.4, 0.5, 0.3. Okay, so first we have to denote the events. So what are the events? There are 3 events. One is A1, A2, A3. Be the events of ABC becoming managers. Okay, so here A1 means what? It is the event that the person A becomes manager. A2 is what? A2 be the event that the chances, A2 be the event that the person B becoming manager. What is A3? A3 be the event that the person C becoming manager. And here they are asking about if they are becoming managers, what is the probabilities that the office canteen will be improved. So therefore, let B be the event that the office canteen will be improved. Okay, so what you have to find out, you see the question. In the question, what is asked? If the office canteen, what is it? You see now, if the office canteen has been improved, if the office canteen has been improved, what is the probability that B was appointed as the manager? So, P of, first which one happened? Our office canteen has been improved. So, that condition happened. On that, we have to find what is the probability that B becoming manager. So, the person B becoming manager is nothing but the event A2. So, therefore, what is asked? P of A2 by B. And you see now P of A1. What is A1? The person A becomes manager. So the chances is given 5:3:2. So 5:3:2 means if you add 5 plus 3 plus 2 is 10. So therefore it is 5 by 10. And P of A2, that is equal to 3 by 10. And P of A3 is 2 by 10. Because the ratio is given as what? 5:3:2. Okay, and P of B by A1. What is P of B by A1? So the office canteen has been, if the office canteen will be improved if which one? A, but the person A becomes manager. So that is P of B by A1. So it is given as 0.4. In the same way, P of B by A2 is 0.5 and P of B by A3 is equal to 0.3. These results are given. We have to give the correct, correct notation. So P of B by A1 means what? It is a probability that the office canteen will be improved if A becomes manager. Okay, and what is asked? P of A2 by B. Okay, so P of A2 by B, we can use the Bayes theorem. So how you can write? First P of A2 into P of B by A2 divided by P of B. P of B is what? It is the total probability of the event. Here the office canteen will be improved. So the office canteen will be improved if A becomes manager, B becomes manager and C becomes manager in some percentage. So therefore P of B is equal to P of A1 into P of B by A1 plus P of A2 into P of B by A2 plus P of A3 into P of B by A3. So the results has to be substituted. Here 0.4 it is in decimal, so I have written as 4 by 10. So in the same way 0.5 is 5 by 10 and here 0.3 is 3 by 10. If you multiply, it is 20 by 100 plus 15 by 100 plus 6 by 100. So that is 41 by 100. Now we'll come to the question. This is the question is asked. We have written the formula. So on that we have to substitute. What is P of A2? It is 3 by 10. What is P of B by A2? It is 0.5 divided by the total probability we have found as 41 by 100. The 0.5 can be written as 5 by 10. If you multiply, it is 15 by 100 into 100 by 41. So therefore 100 getting cancelled. Your answer is 15 by 41. See the fifth problem. An advertising executive is studying television viewing habits of married men and women during prime time hours. Based on the past viewing records, he has determined that during prime time, wives are watching television 60% of the time. You see that now? Wives are watching television during the prime time is 60%. Okay, and it has also been determined that when the wife is watching television, 40% of the time the husband is watching. When the wives are watching, husband also watching how many times? It is 60% of the time. And the second one, you see that when the wife is not watching the television, 30% of the time the husband is watching the television. You see here what is given? When wife is not watching, husband is watching the television is 30%. Okay, see what is asked? Find the probability that the husband is watching the television during the prime time of television. And the second one, if the husband is watching the television, the wife is also watching the television. Okay, so the results are given for these three. Then the two subdivision is asked. Okay, so first one, you see, wives are watching TV during the prime time is 60%. Okay, and wives are not watching the TV the remaining time. So what is the remaining percentage of time? It is 40%. So we have to take from this one result. Wives are watching TV 60% of the time means wives are not watching the TV 40%, isn't it? And what is this 60%? When wives are watching, husbands also watching. The 30% is given when the wife is not watching, the husband is watching the television. Okay, so here we have to denote the events. You see the events here. A1 be the event that wives are watching television during prime time hours. And let A2 be the event that wives are not watching television. Okay, A1 is what? This is the another word. This is the event that the wives are watching television during prime time hours. This A2 be the event that wives are not watching the television. Okay, here we have to consider B. The B be the event that the husband is watching television. Okay, what is A1 intersection B? When the wife is watching, husband is also watching. Okay, both are watching the television, means that is A1 intersection B. Here what is A2 intersection B? When the wives are not watching, the husband is watching the television is A2 intersection B. Okay, here we have to find out P of A1. What is A1? The event that the wives are watching television. Here in the problem what is given? When the wives are watching TV during the prime time is how much percentage? 60%. So therefore 60 by 100. What is A2? A2 be the event that they are not watching the television. So P of A2 is nothing but 40%. How the 40%? 60% of the time they are watching, means the remaining 40% of the time they are not watching. So therefore 40 by 100. Okay. So the next one. P of B by A1. What is P of B by A1? It is wives or P of B by A1. So when the wives is watching the television, the husband is also watching. That is 40 by 100. And P of B by A2 is what? When the wife is not watching, the husband is watching the television. It is given 30%, so therefore it is 30 by 100. Okay, so here what is the first question is asked? The first question is find the probability that the husband is watching the television during the prime time of television. So husband is watching. Okay, so that event is what? B. So we have to find out P of B. So P of B means how you can find P of A1 into P of B by A1 plus P of A2 into P of B by A2. So P of A1, what we have written, it is 60 by 100. P of B by A1 is 40 by 100. And P of A2 is 40 by 100 and P of B by A2 is 30 by 100. So if you multiply, it is 2400 divided by 10,000. Here 40 into 30 is 1200 divided by 10,000. So if we cancel two zeros, it is 25 by 100 plus 12 by 100, that is equal to 36 by 100. If we cancel with 4, it is 9 by 25. See the second subdivision. If the husband is watching the television, the wife is also watching the television. So the husband is watching the television, that event is B. So it happened, this condition already happened. So it is denoted in the denominator. If the husband is watching the television, what do we have to find? What is the probability that wife is also watching? So wife is watching the television, that event is A1. So we have to find out P of A1 by B. So using the Bayes theorem, what is the formula for that? It is P of A1 into P of B by A1 divided by P of B. P of A1. So we have written P of A1 as A1 is the event that wife is watching the television. So it is 60 by 100. And P of B by A1. What is A1 here? A1 means its wife is watching when what is the probability that husband is also watching. So therefore it is 40 by 100 divided by P of B. So it's a total probability that the husband is watching the television is 9 by 25, or we can write 36 by 100. Both are same only. So when you multiply, two zeros getting cancelled. So 6 4s are 24 by 100. So if you reciprocate this, it is 100 by 36. So 100 getting cancelled. So the answer is 24 by 36. So if you divide it by 12, the answer is 2 by 3. Thank you, students.